I mentioned earlier under these sections, IDS, IPS, and then the alarm categories, how difficult it is for these systems to be written and configured and programmed. It's very, very difficult to get 100% so that only real alarms are actually tripped and only that all non-threats will not have an alarm. It's hard to get 100% on these things. You might hit 90% at first, and then you hone your rules a little bit and you get 92%, and you just keep getting better and better and better, hopefully. But those false positives and true negatives will still occur once in a while. So what do these rules look like, and what are the different ways that we can program these things to recognize intrusions? Well, there are basically three. There is a signature-based detection type, and then there is a statistical anomaly-based and stateful protocol-based. So let's talk about what these things mean. Signature-based is very much like an antivirus software, a piece of software. So it's based on our understanding of what different attacks look like. So, for example, there might be 3 dozen distributed denial of service programs that are known, and what those DDoS attacks look like for each one might be just a little bit different. But if we can write rules that recognize each of them, then we know right away to shut down when those happen. This is probably the best type for actually making sure that that attack is actually real when it does happen, but it might also miss a lot of attacks. So because some attacks, it's hard to, we don't have a signature for all attack types, especially ones that are custom made. So we have another kind, statistical anomaly, and what this does is it just monitors the system, creates a baseline of what our network looks like. What does traffic on our network look like? Does it start out high in the morning at 8 o'clock? There's more email going around at 8 o'clock in the morning. Does it dwindle down over the day, or are there times of the day that it gets more? Are there certain kinds of traffic that move around at different times of the day? And that kind of thing, so that we have these patterns. And there's lots of different types of patterns that we could do. File sizes, use of certain protocols, as well as simply amounts of traffic. So these things just look for changes in the way our network is being used, and if there's a significant change, it might throw up a red flag and say, hey, we might have a problem here. Third is stateful protocol analysis. So this is just based on our understanding of what protocols should look like. So for each protocol in the TCP/IP protocol stack or protocol suite, we have rules. They're usually in the term of what we call RFCs, of how this protocol should look. What should be in the header? Where should it be? What flag should be set when? That kind of thing. So that if we understand what these protocols should look like, then we can recognize when they don't look right. One example that I gave here in the text is that, let's say that, I don't see where I put it now. I know it's in here somewhere, but let's say that, oh, it's down here. I was looking in the wrong spot. Oh, no, I put it down here in this list. Okay, sorry about that. Flags. Certain packets should only have certain flags turned on. But what happens if a packet comes in with all the flags turned on? That happens to be a type of attack called a Christmas tree attack, and we need to recognize that pattern, because that is not the way those protocols should work. So that is our stateful protocol analysis.